Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to ask the question, why do we even need Microsoft Azure? And I'm going to try and answer it too. And in so doing, I'm going to attempt to introduce some new concepts and terms that'll be important as we move forward in this series. And it's tempting to, as a programmer especially, to just jump right in and start showing you how to do all this cool stuff, how to perform certain tasks in Azure. But that's not how my brain works anymore. I think the fundamental problem with jumping right in from the very get-go is that you begin climbing trees before you really start to get your bearings in the forest, or even why you're in the forest in the first place. And there's going to be plenty of time for those how do I style topics later on in this series. But if you want to learn, and I mean you want to really learn Microsoft Azure, then you need to be grounded in the foundational concepts. In other words, the why behind the how. And so that's what I hope to do. So before we get started, I have to trust that you already understand a lot of things because we don't have a lot of time and I want to keep this concise. So I trust that you understand these things before we even get started. And this is kind of a long list and it covers a lot of ground. But you should already understand the basics of client-server architecture, and you understand some of the challenges that it presents. You should already understand that as you add more clients, or in other words, more load to a system, that you might need additional servers, additional compute resources to handle that load. Otherwise, there's going to be a lag, or worse, there could be timeouts for the client. You should already understand that your application will ultimately be judged on its reliability, its availability, and its maintainability. So let me define those very quickly to make sure we're on the same page. Reliability measures the likelihood that any given request or function in the system will produce the desired result and it's not going to produce an error. So that's reliability. Availability measures the likelihood that a system is up and running and that it's ready to handle a request at any given time and it's not going to time out. So that's availability. And then thirdly, maintainability measures the relative ease to restore a system back to a running state should it ever break down. Maintainability. So designing for reliability, availability, and maintainability means that you need a strategy to expand compute resources very quickly on demand. So a common solution for this is to either scale up or to scale out. So you should already know about these two terms, but let me just cover them really quickly here. You typically choose to scale out when any single request demands more memory and processing power to complete, and the bottleneck or the latency in the system is the intensive number of software objects that are created, or the algorithms that are used, or the business logic that's being relied on. In this case, the key to completing each incoming request is to provide each incoming request with more processing power. That's scaling up. Conversely, you scale out when any single request requires less memory and processing power to complete, or at least that's not really the latency in the system. However, you're waiting for network communication or disk access. So in that particular case, the key to completing each incoming request more efficiently is to run it in parallel to other requests, and so that they each can be working and waiting on external components to complete disk access, network access, whatever have you, and so they're running in parallel. So, and these two ideas are not mutually exclusive. It's common to both scale up and scale out for any given system. So you purchase more computers, each computer with more memory and a better processor. All right, so you should already know that. And you should already understand that scale out is made possible through a network component called a load balancer. The load, in other words, the number of incoming requests, is balanced between two or more servers. And there's a couple of different ways to do this balancing. One of the most common and easy to comprehend is round robin, where you've got maybe 5 servers. You give the first request to server 1, the second request to server 2, and so on until you get to server 5, and then the next request goes back to server 1. That's round robin, all right? And you should already understand the importance of redundancy in a system. And redundancy within a software system takes many different forms. One of the forms is that you can create copies of a system that are ready to take over should there be any problem in the primary system that handles all the incoming requests. So for example, if your primary database server goes down, traffic can be routed temporarily to a mirrored version of that database. This routing to a mirrored copy is often called a failover. All right. You should also understand that you can also gain redundancy by using a technology called clustering, which involves using multiple physical server machines, and then you tell the operating system that you want to treat all of those machines kind of as a single unit. So now these individual machines are all appear to the operating system to be a single machine. So if the hardware fails in any one of those, there will be little or no downtime because it's just automatically routed to the other hardware to handle a given request. Whenever that other component of the cluster comes back online, it can be given responsibilities in the system again. You should already understand that redundancy can be introduced for an entire data center, so that if one data center goes down, network traffic will fail over to a geo-redundant version of the data center. In other words, somewhere across the town or across the world, you've got a copy of the data center, and you can route all incoming traffic to that other data center to handle the load. And finally, you should already understand the value of virtualization and how you can quickly give applications or websites that are experiencing an unusually heavy spike in requests by simply copying the virtual machine file, literally, creating copies of that to a cluster of hardware that's managed by software called a hypervisor. And so you can scale up or scale down resources inside of your own organization using virtualization, which is kind of one of the foundational concepts of the cloud in the first place. So that is the baseline knowledge that I really didn't want to spend time going over and being thorough about. I wanted to trust that you already knew some of those sorts of things. But if any of these ideas are unclear to you, then just all you need to really understand them is at a very high level. But you might want to take a few minutes, look at these terms in Wikipedia. It's often a great place to get a quick overview. And then you can come back and you should feel fine with what we talk about from here on out. So you might wonder, how does all this apply to Microsoft Azure? Well, I've named off maybe half a dozen different strategies and patterns and techniques that companies have used for decades to create applications that are reliable, available, and maintainable. Furthermore, companies have invested a fortune in implementing each of these within their own data center. Servers, software licenses, the people to actually make it all work are extremely expensive for businesses. And furthermore, getting it all wired up and working correctly is extremely time-consuming. So herein lies the opportunity for cloud computing and for Microsoft Azure specifically. Affordability, speed to market, and a vast array of options, all presented in a very simplified, accessible little dashboard with great redundancy and failover options to keep those applications up and running and making the company money even if something bad happens. So with Microsoft Azure, first of all, you can provision new servers to handle an increase in load in seconds and minutes rather than waiting days or weeks to get new hardware into your data center and get it all set up. It's so easy to do this, in fact, that I taught a high school kid how to do this in just a few minutes. Super easy. Also, with Azure, you can scale back down when you no longer need those compute resources. So that's something that you can't easily do when you own your own server farm with your own physical servers. And in most cases, with Azure, you can do this automatically without human involvement. So you can set up these rules, these thresholds of when it gets to this saturation level in terms of memory or network access or processor utilization. Then Azure can take care of the rest. It can spin up new instances of your application and new virtual machines, or it can increase the hardware that's required to do that by increasing from a small compute instance to a medium or a large instance. You have a lot of options in that regard. Also, load balancing, like we talked about a moment ago, it's baked into Azure services. It requires very little configuration. Redundancy, it's baked into Azure at various levels, from something as simple as failing over within the same data center to failing over to dozens of different data centers around the world. And if your company's already using virtualization, you can leverage existing investments and increase the computational capacity of your virtualized farm without having to buy new hardware. You just upload your virtual machines into Microsoft Azure and host them there and scale them out as you need to. And with Azure, you don't have to totally buy in and completely convert to Azure. You can ease into the short end of the pool, and you can use a hybrid approach. You can have some on-premises components of your application architecture and some Azure-based components, and they can all work together and talk to each other. All right. And best of all, from a business perspective, you didn't have to spend millions of dollars to get all this, and you don't have to spend millions of dollars to just get started. You can start for free, usually, in just a matter of moments, and test the waters before you jump in with both feet. And it's because of all of these reasons that I'm confident, all things considered, that utilizing Microsoft Azure is probably the most cost-effective way to implement these things rather than building your own data center to accomplish these things. Now, I know for a fact that some people would bristle when I suggest that, but businesses always need to consider the trade-offs. First of all, from a people perspective, should you spend time and money building employee competency in low-level infrastructural pursuits like provisioning, maintaining, patching, repairing hardware, and so on, instead of investing in some higher-level business problem that'll actually make the company money? From a hardware perspective, do you want to take on the expense of building out a data center? Do you want to invest in the hardware to meet the growing demand, or just a temporary spike in demand? Or can I spend that time and that money somewhere else where it makes more sense for my company? Do I provision enough servers to handle a future demand that we can't predict? Or do I provision enough servers just to meet today's demand and risk the possibility that I can't meet tomorrow's demand and I'm going to have frustrated customers or users? Either way, I'm going to be wasting money or making somebody mad, right? So in addition to all of these sorts of things, in addition to the scaling story, the redundancy story, the failover story, Microsoft Azure introduces new and in some cases more elegant ways of doing things that we've done in the past, of doing old things. In other words, it gives you, the software architect or the system architect, more architectural options as you design your applications. And furthermore, there's typically not just one new way to do something, but several different Microsoft Azure services or technologies that could be leveraged to address any given need. And usually which option you wind up choosing greatly depends on how much control or responsibility that you want or that you need to take on. We'll talk about that more here in an upcoming module. And finally, I think it's important to point this out too, that I've been talking primarily about scenarios for larger companies, but Microsoft Azure has something for everyone. From the one-man startup like me to a Fortune 500 company. In fact, half of Fortune 500 companies use Microsoft Azure in some capacity, and a growing list of startups take advantage of the BizSpark program. You may have heard of that. It gives them access to Azure for free up to a certain point, and then it's discounted from there on. So as a small business, you have access to the kind of compute, storage, failover and big data analysis capabilities that large companies have been using for years to keep you down, all right, as their competitive advantage against you. So to recap, in most client-server applications, there's a varying demand for compute and storage resources. And this could be due to seasonal demand, due to some business constraint, or just due to the growing popularity of your website or your applications within the organization. And in the past, companies have had no choice but to heavily invest in hardware and software licenses, invest in manpower in order to scale up and scale out to meet those needs. And despite spending a lot of time and money, there was typically a potential gap in time between the moment that a need surfaced and the moment where new servers were actually provisioned and deployed to meet that need. And that gap in time led to frustrated users. It led to missed opportunities and sales lost and things of that nature. But now, cloud computing with Microsoft Azure provides another option to bridge that gap. In just a matter of minutes, Microsoft Azure can be tapped, to handle an unexpected spike in compute cycles or storage capacity, and businesses then only pay for what they use in typically a minute-by-minute basis or a megabyte-by-megabyte basis, whatever the case might be. Furthermore, businesses can benefit from Microsoft's investments in redundancy, even geo-redundancy, as well as failover and caching and storage and machine learning and authorization services and a lot more without having to spend the money or build the competency to build that out themselves. So hopefully I've answered the question why Azure in a very concise way. Hopefully now you can see why we're standing here at the forest in the first place. And so now that we understand why we're even standing here in front of this forest, we'll start getting a sense of how the forest is laid out, where the paths are, and so on in upcoming modules. Thank you very much.